Welcome to Chapter 6. This chapter is on selecting research participants, and we are getting to that step where we will need to get our participants that will take our questionnaire that we're going to be making. And so we're going to discuss today the different methods for doing that. And so, one of the assumptions of inferential statistics is that we randomly select samples from the population. However, this is rarely the case in the real world of psychological testing. Most research is actually done using college students in intro to psychology classes. So we violate this assumption because usually we are more interested in testing a hypothesis than we are in describing a population. So as long as our theory applies to our participants, then we are usually safe not actually randomly selecting people. If our research goal is to describe a population, then we have to randomly sample. And then when we're going to do true random sampling, the first step is to develop what we call a sampling frame, which is just a fancy word for a list of the population. So if we wanted to get the sampling frame for all the students at the college, it would just be a list of all the names of students that are enrolled at the school. And so sampling frames are often incomplete or they don't exist. You can imagine that students are adding classes and dropping classes, and so maybe administration isn't able to keep up the records like on a second to second basis. So it's possible that the information might be delayed or inaccurate due to other reasons. And so the other kind of issue with obtaining a true sampling frame is that the college registrar may not release student information. Student information is protected, obviously, there's privacy laws, and so it would have to really be a good scientific reason for collecting that data, and it would have to pass through a bunch of, provisions first and get approval before a researcher would be able to just access a student body's information. So the point is, getting a list of all the names in a population that is up to date, that is accurate, that doesn't violate people's rights is pretty difficult. And so because of that, we can't just do true random sampling all the time. We have to have these other sampling methods. And so chapter 6 is talking about all of these different sampling methods. So let's dive in. So there are two broad categories of sampling methods. We have probability sampling methods and non-probability sampling methods. And so this lecture is going to break down all the types of sampling that fall under both of these categories. But before we look at the specific methods of sampling, let's get our definitions for probability sampling and non-probability sampling, the two broad categories. So probability sampling methods can specify the probability that a participant will be selected from a population. And this allows you to be confident that your sample is in fact representative of the population. What it also does is it allows other researchers to replicate your selection procedure and obtain similar samples. So even the way we go about collecting our samples, we report that in our papers. And when other researchers go to replicate our research, they look to the sampling method that we used, and then they would do the exact same sampling method so that all aspects of the study are the same in replication. And then there's also non-probability sampling methods, and these make it impossible to specify the probability of selecting any one individual, unfortunately. So the sample may or may not be truly representative of the population. And so the reason that this is allowable in hypothesis testing is that with hypothesis testing, the point of our study is not really to describe the population to an exact T, but instead it intends to test a theory. And so that's the way that researchers kind of work around not being able to use probability samples all the time. However, of course, we would prefer probability sampling to non-probability sampling, but it's difficult to get research participants. And so sometimes we have to use non-probability sampling when we'd really prefer to not. Okay, so let's watch a video that kind of goes over everything we're going to talk about in this lecture quickly, just to introduce you to the concepts. So this video is all about sampling methods.
Hi, I'm Adrienne Hill. Welcome back to Crash Course Statistics. In our last episode, we talked about how we use experiments to imitate having two parallel universes to test things. But sometimes you can't do certain experiments without becoming an all-powerful and evil dictator. And since it's statistically unlikely that any of you are evil dictators, today we'll explore those methods. Like we mentioned at the beginning of the series, you're not always able to answer the questions you really want to answer using statistics. For example, it would be great to experimentally test whether getting married increases your lifespan, but you can't randomly assign some people to be married and force another group to be single. Not only would that be difficult to enforce, it would also be pretty unethical, though I suppose you being evil takes care of that particular concern. Similarly, we can't assign someone to be a twin, or a Democrat, or a smoker. But that doesn't mean we should just give up and stop trying to find out more about all these topics. Not at all. Instead, we just need a different method to collect data. Enter non-experimental methods. One of the most common non-experimental methods is the survey. From user experience surveys on websites to political polls to health questionnaires at the doctor's office, you've probably taken hundreds of these surveys in your lifetime. There are two things that can make or break a survey: the questions and who the researcher gives the questions to. The goal of a survey is to get specific information. Say you're walking your dog in a local park and someone approaches you and asks you to take a survey on local businesses in your town. When you look at the questions, you notice none of them are about local businesses. Instead, you find yourself answering questions about your politics and religious beliefs. Unless the surveyor was lying to you about their purposes, this is not a very good survey. It's also not a very good lie. A survey should measure what it claims to measure. It might seem obvious that having only unrelated questions on your survey is problematic, but there are even more subtle ways a question can be biased. Let's take a look at a few questions from a health survey you might find at the doctor's office. The first question asks you how often you exercise. Never, less than 30 minutes a week or 30 minutes a day. But what do you answer if you exercise for half an hour twice a week, or if you're on a swim team and exercise for at least an hour a day? And does dog walking count as exercise? Multiple choice questions that don't offer all possible options and/or an other option can cause respondents to either skip the question or feel forced to choose an answer that isn't accurate. Claims made using these questions aren't as strong as they could be if people were offered a full range of choices. The next question at your doctor's office asks you, answer yes or no. I don't smoke because I know it's damaging to my health. This is a leading question, since the wording leads towards the, quote, desired answer. This is especially effective when a question deals with sensitive issues like smoking, politics, or religion. People answering the questions want to be seen in a positive light, and so they tend to give the answer they think is appropriate. While having people fill surveys out anonymously by themselves can help, it can sometimes be the case that respondents don't want to admit things, even to themselves, that are socially undesirable. In general terms, good survey questions are worded in a neutral way, such as asking, how often do you exercise? Or describe your smoking habits, instead of using wording or options that push survey takers in a certain direction. And while your doctor wouldn't or shouldn't do this, sometimes groups purposely use biased questions in their surveys to get the results they want. Apparently, back in 1972, Virginia Slims conducted a poll asking respondents if they would agree with the following statement. Quote, there won't be a woman president of the United States for a long time, and that's probably just as well. Not a well-written question. Bias questions can be more subtle and can lead to very skewed reports of very serious things like sexual assault or mental health conditions. It's important to always look for biased questions in surveys, especially when the people giving the survey stand to benefit from a certain response. Even when researchers have created a non-biased survey, they still need to get it into the right hands. Ideally, a survey should go to a random sample of the population that they're interested in. Usually, this means using a random number generator to pick who gets the survey. We do simple random sampling, so there's no pattern or system for selecting respondents, and each respondent has an equal chance of being selected. For example, telephone surveys often use random digit dialing, which selects 7 random digits and dials them. When someone picks up, they're asked to take a survey. But here's where we hit our first issue. If people aren't forced to respond to the survey, we might experience something called non-response bias, in which the people who are most likely to complete a survey are systematically different from those who don't. For example, people with non-traditional working schedules like retirees, stay-at-home parents, or people who work from home might be more likely to answer a middle-of-the-day phone survey. This is a big problem if those groups are different than the population as a whole. If your survey was on health insurance plans or political opinions, it's likely these 3 groups would have different opinions than the population, but they represent the majority of survey responses, which means your data won't represent the total population all that well. This is also related to voluntary response bias, in which people who choose to respond to voluntary surveys they see on Facebook or Twitter are people who, again, are different than the broad population. This is especially true with things like customer service surveys. People who respond tend to have either very positive or very negative opinions. See the comment section below. The majority of customers with an average experience tend not to respond because service wasn't noteworthy. Wait, does that mean I'm not noteworthy? Another source of bias is just plain underrepresentation. If a group of interest is a minority in the population, random sampling paired with response biases might mean that minority isn't represented at all in the sample. Let's say there's a city where 5% of the population is single mothers. It's entirely possible that the sample will contain no single moms. To overcome these issues, we have a couple options. We could weight people's responses so they match the population, like counting the few single mothers who do respond multiple times so they end up counting for 5% of the total sample. But this can be problematic for the same reason that response bias is problematic. If the few single mothers who respond don't represent all single mothers, our data is still biased. In a 2016 LA Times USC political tracking poll, a 19-year-old black man was one of 3,000 panelists who was interviewed week after week about the upcoming presidential election. Because he was a member of more than one group that was underrepresented in this poll, his response was weighted 30 times more than the average respondent. According to the New York Times, his survey boost his candidate's margins by an entire percentage point. Stratified random sampling is another option. It splits the population into groups of interest and randomly selects people from each of the stratas so that each group in the overall sample is represented appropriately. Researchers have used stratified sampling to study differences in the way same-sex and different-sex couples parent their kids. They randomly select people from the same-sex parenting group and randomly select people from the different-sex parenting group to make sure they're well represented in the sample. Another issue is that getting surveys to people can be expensive. If a cereal company wants to see how families react to their new cereal, it would be costly to send some cereal to a random sample of all the families in the country. Instead, they use cluster sampling, which create clusters, not honey nut clusters, that are naturally occurring, like schools or cities, and randomly select a few clusters to survey instead of randomly selecting individuals. For this to work, clusters cannot be systematically different than the population as a whole, and they should about equally represent all groups. Issues can also arise when the population being surveyed is very small or difficult to reach, like children with rare genetic disorders or people addicted to certain drugs. In this case, surveyors may choose not to use randomness at all and instead use snowball sampling. That's when current respondents are asked to help recruit people they know from the population of interest, since people tend to know others in their communities and can help researchers get more responses. And note here that these sampling techniques can and are used in experiments as well as surveys. There are other non-experimental data collection methods, like a census. A census is a survey that samples an entire population. The United States conducts a census every 10 years. The next one is scheduled to be done in 2020. It attempts to collect data from every single resident of the United States, even undocumented residents and homeless residents. As you can imagine, this is hard, and it's not without error. In medieval Europe, William I of England conducted a census in order to properly tax the people he had conquered. In fact, fact, a lot of rulers tend to use censuses to know just how much money they should be demanding. Until the widespread availability of computers, the US Census data took almost 10 years to collect and analyze, meaning that data from the last census wasn't even available until right before the next census. The length of time it took to complete the census is part of the reason we have computers. Check out our Comp Sci series for more on that. So why collect census data instead of just sampling the population? In the US, the census could cost more than $15 billion in 2020. There are a lot of reasons. I mean, the Constitution says we have to, but also the census provides the truest measure of the population we can get. It minimizes sampling error. It also functions as a benchmark for future studies. And a census can give researchers really specific information about small groups of the population, information that might be hard to gather with regular sampling methods. And doing statistics on census data is different because most statistical inference aims to take a small sample and use it to make guesses about the population. But with a census, we already have data from the entire population. We don't need to guess if there are differences. We can just see them. Analysis on census data is usually more concerned with whether differences we see are large enough to make a difference in everyday life, rather than guessing if there is a relationship. The census, as we said, can take years and entire countries to fund. That doesn't discount the value of sampling, but we should be cautious. Badly worded polls, fake polls, and biased polls are common. So are the results of those polls. The statistics-friendly website 538 put together a great list of advice on how not to fall for a fake poll. Among its advice, ask yourself if it seems professional. Check to see who conducted the poll, and if you trust them. See how the poll was conducted. Check out the questions they asked and who they asked. If it seems fishy, it probably is fishy. That said, well-done surveys are essential. They allow us to get information without all the trouble of doing an experiment. And since they're comparatively easy, they're popular ways for businesses, countries, and even YouTube channels to collect information. In fact, Crash Course Statistics has its own survey. The link is in the description. And it takes way less time than the Nerdfighteria one. I promise. Thanks for watching. I'll see you next time. Crash Course Statistics is filmed in the Chad and Stacy Immigholt studio in Indianapolis, Indiana, and it's made with the help of all these nice people. Our animation team is Thought Cafe. If you'd like to keep Crash Course free for everyone forever, you can support the series at Patreon, a crowdfunding platform that allows you to support the content you love. Thank you to all our patrons for your continued support. Crash Course is a production of Complexly. If you like content designed to get you thinking, check out some of our other channels at complexly.com. Thanks for watching.
Okay, so we are going to start with probability sampling, and the first sampling method under that category of probability sampling is random sampling. Sometimes it's referred to as random selection, but they're the same thing. And so random sampling or selection is a procedure where each member of a population has a statistically equal probability of being included in a sample. So the likelihood of me being selected is equal to the likelihood of anyone else in the population being selected for the sample. And so with small populations, to do a random sample, we can just put names in a hat and draw for participants, for example. But with large populations, it gets a little more complicated. And so the old school way of using random sampling with large populations was to look in the back of a statistics textbook, and there would be a table of random numbers like you see here on your screen, and you would use that to choose participants. So what you would do is you would have that list of all the names of students that attend the college, let's say, and each name would have a number. So, it'd start in alphabetical order with the A's, and it'd be like Alan Abraham is student number 1, and then Alan Atticus is student number 2, and so on and so forth. And then when you go to the textbook, you just look for the table of random numbers, and then it tells you what students to pull. So you're going to pull student 61,424 or student 90,222. And so it's random because you don't really know whose number matches up with what name. The textbook is telling you who to choose by these numerical IDs. But that's pretty old school. Nowadays, we use the internet of course, or an app. We use generally what's called a random number generator, and you can just Google that, and there's a ton of options that pop up. But I'll show you one that I like to use. Research Randomizer website, and it is used for random sampling and random assignment. But I'm going to go ahead and just generate some numbers for a random sample. And so what I would do is I would first tell it how many sets of numbers do I want to generate. And so this is essentially how many samples do you need. And so we're just going to need one sample. And then how many numbers per set. So how many people do we want in our sample? So for this class, we need a minimum of 85 for our research studies. So we're going to just put 85. And then the number range, we're going to go back to our sampling frame or our list of names in the population. And we're going to tell this website, the randomizer, basically the range of the numbers. So from 1 to what's the last student's number, and let's say it's 10,000. So do you wish each number in a set to remain unique? Yes, we don't want to duplicate we don't want to duplicate any numbers. And then do you wish to sort the numbers that are generated? No. And how do we want to view it? Place markers off. I don't really know what that means, to be honest. Okay, randomize now. And so here it is. I would go back to my sampling frame or my list of students at the college, and I would get student 4,029, student 3,094. So this is 30 numbers that is going to comprise, this is 85 numbers that's going to comprise the people in my sample. And so that's how we use a random number generator. So obviously the problem with the random number generator is that these numbers pop up. You got 85 participants, you reach out to those people, and are all 85 of them going to say, yes, I can participate in your study? Maybe not, right? And so that's what kind of creates the problem with true random sampling is really getting everybody to participate in your studies. So one way that you can kind of attempt to rectify that is by creating your own pool of people that are willing to participate in psychology research. So Stanford University does something like this. So I wanted to show you their website for research participation in the psychology department. And so they allow anybody to participate in their research. You can just come here to this website, click on sign up to participate, and then you'll see here is a survey to collect just kind of basic information on participants. So am I 18 or older? Yes. Do I live in the US? Yes. And then you'll notice that here we have some identifying information. So generally in research, we like our participants to feel like they're anonymous and that their responses are completely confidential, that their identity is sealed, and nobody has any way of ever knowing what they put on these studies. But if you're asking for my first name and last name, it seems like you could probably track my data, right? So what they're trying to do here is create kind of a sampling frame. And so they're collecting first and last names of people to create this sampling frame. So let's say they get 10,000 people that are willing to participate in studies. And then they can use a random number generator and pick the 30 they need for their sample or whatever out of this sampling frame that they're getting from doing this survey here. So it's still not true random sampling because people are signing up that are aware of this website, and so that makes it not an equal probability that everybody in the population has a chance to get in this sample. It skews towards people that know about this website, right? Maybe they know about this website because they are in a psychology class at a college versus some students who, haven't taken a psychology class or don't need to. And so those people do not have the same opportunity to get in this sample as the psychology students. And so while it's not a perfect random sample or a perfect attempt at random sampling, it's good because it at least kind of creates the sampling frame and then people are pulled from that randomly. So you have a better chance of those people actually showing up than just getting a list of people from college admissions or administration and then going, hey, I saw you on this list, and then I used a random number generator, and you popped up, so you want to participate in my study? It's a little bit harder to obtain people like that, but at least if you do what Stanford does and you have a sampling frame of people that are willing to participate, then you have a better chance of them actually showing up on the day of the research or taking the online survey or whatever. So again, this is this random sampling, true random sampling, is rarely used in social science experiments, but what is almost always used in experiments is random assignment. So a lot of students get random sampling and random assignment confused. So to be clear, random sampling is when we randomly select people from a population. Then we have our sample. They show up on the day of our research. They're at the door of the lab. And then we have to either put them in the control group or the experimental group. So we either assign them to group 1 or we assign them to group 2. But the way we go about assigning them has to also be random. We can't just eye people up and down as they walk through our lab and then decide if they're going to be in the control group or the experimental group. Because obviously there could be some bias there. So we have to randomly assign them to the control or the experimental group. And you can do that easily. I just use a coin flip app on my phone, and then when the participants walk through the lab doors, they tap the phone, and if it lands on heads, they go in the experimental group, and if the coin lands on tails, they go in the control group. And so that's random assignment, different than random sampling. Okay, so let's watch this video on random sampling now.
So how can a survey of a small group of people measure public opinion of the entire United States? This idea is called random sampling, where instead of talking to everyone in the population, you talk to a group of people who represent the entire population. Of course, if you want to measure what the entire nation thinks, you can't just stand on a street corner and wave people over. That type of haphazard sample would only represent the people near that street corner at that particular time, and you wouldn't get the people that didn't necessarily want to talk with you. A nationally representative survey requires a random sample in which each person in the United States had a chance of selection. Survey researchers have spent decades perfecting methods to draw a truly random sample that includes all ages, all incomes, all ethnic and racial backgrounds, and all political persuasions. We actually use random sampling all the time in everyday life. For example, when you're making soup, if you stir the pot correctly, you don't have to drink the entire pot of soup to know if it needs more salt. Instead, you can just have a spoonful, because each spoonful tastes like the pot of soup overall. That's random sampling. So once you have your random sample, how can you ensure that it actually represents the overall population? A sample could differ from the overall population because some people are more likely than others to take surveys. So pollsters use a standard technique called weighting to adjust for differences. We know the demographic composition of the United States thanks to data from the U.S. Census Bureau. So once we have our sample, we compare the respondents' demographics to the makeup of the whole country. We look at things like age, gender, education, race, and region. Weighting allows us to adjust our survey data so that it matches the general population on these characteristics. So because of random sampling and weighting, we can take something small like a survey sample and use it to describe something much larger, like the attitudes of all U.S. adults.
All right, so the next sampling method we are going to discuss is still under the category of probability sampling, and it is called systematic sampling. And so this type of sampling is just done when we choose every nth individual in a population. So we have our sampling frame, our list of everyone in the population, and then we say, okay, we're going to pick every third person on the list or every fourth person on the list. So let's say that we needed 100 participants, and our sampling frame contains a list of 400 people. What we would do is we would take that 400 and divide it by 100, and that would give us 4. And so we would just then use systematic sampling and take the fourth person on the list, so every fourth individual. And so you have to make sure that the organization of your list can't bias your sample. So, for example, if the list was organized boy, girl, then you would only end up with girls in your sample. So you kind of have to watch out for that with systematic sampling. Okay, so let's go ahead and watch a video on systematic sampling.
Today's video follows directly after our video on simple random sampling and covers what we call systematic sampling, or sometimes referred to as systematic random sampling. The difference between the two titles is really semantics, and the process is exactly the same whether you're doing systematic sampling or systematic random sampling. Remember that systematic sampling is a type of probability sampling, where we use the mathematical meaning of chance to select from our population a sample that will accurately represent the population. This assures that each case in our sample has a known and equal chance of being selected. This creates an unbiased sample. But how does systematic random sampling actually accomplish this? How does it pull it off? Well, as it turns out, systematic random sampling is very much a process conducted through a series of steps. Perhaps this is not surprising given its title, systematic sampling. Step 1 of this process involves acquiring a list of everybody in our population. Just like in simple random sampling, in systematic sampling, the quality of the list matters a lot. Essentially, we want a list that has no omissions, that is, nobody is missing, and no duplications, where nobody appears more than once. It's important to keep in mind that just like in SRS, perfection is the goal, but not the reality, and we often have to settle for an imperfect list. Once we have our list, step 2 involves creating a sampling fraction. You may recall that the symbol for sampling fraction is k, and k is determined by taking the size of your sample and dividing it by the size of your population. So for example, if we had 1,000 people in our sample and we had 16,000 people in our population, k would be 1 over 16. Step 3 is where we select our first case. For example, we determined in step 2 that k equaled 1 over 16. We therefore need to select a number at random between 1 and 16. But why 16? Remember in our hypothetical example, we wanted to select 1 out of every 16 cases. So 16 was determined by k. Once we've determined the number of cases that we have to select from, the next step is rather simple and might look familiar. That's right, we simply need to put 1 through 16 into a hat, a box, or a bin, and then pull out randomly one of the numbers. In step 4, we come back to the list. We need to select our first case. We do this by picking the case off the list that we chose in step 3. In this case, it'll be between 1 and 16. Step 5 is the most systematic of the steps. This is where we take every kth case after we select our first case. The kth case is unsurprisingly determined by k, which is simply, again, the size of our sample divided by the size of our population. Let's say, for argument's sake, in step 3 we chose 9 out of the hat. This would be our first case, or case number 9. We then would take every 16th case after that, so this case 25, 41, 57, and we would stop once we've selected out 1,000 people for our sample. As it turns out, this process is equally as random as simple random sampling. I've had many students question this and say it simply can't be true. I assure you it is, and that is because our first case was selected completely at random. So while each remaining case is taken at an equal interval, they are equally as random. As it turns out, systematic sampling is so useful, it's the most popular way we sample in social science research.
Okay, and the next probability method of sampling is stratified sampling. And so what stratified sampling does is it assures that you will be able to represent not only the overall population, but also key subgroups of the population. So for example, let's say you have a population where there's 80 females and 20 males. And so you want to end up with a sample that is numerically representative of the population. So in your sample, just like the population, you would want to have 80% females and 20% males. So you can't use systematic sampling or random sampling in this situation because you can't be sure that you would end up with this 80% female and 20% male. So what you would have to do is take your population or your sampling frame and divide it into groups of males and females. And so that would naturally give you 80% females and 20% males. And then you would randomly select or systematically select 80% of your sample from females and 20% from men. So in other words, if you had 100 people in this population, 80 of them are females, 20 of them are males. You want 10 people in your sample, so you divide up all the males and all the females, and you pull, to get your sample of 10, you pull 8 females at random, and you pull 2 males at random. And then you would have a sample that is 80% female and 20% male, just like your population. Okay, so we are going to watch this clip from the John Oliver show, and it is just a perfect example of the importance of making sure that our samples are representative of our population, and he uses stratified sampling to kind of represent this idea.
The Earth. You may know it as that blue thing Bruce Willis is always trying to save. Or from its famous collaboration with wind and fire. Or just simply as that place where George Clooney lives. Anyway, the Earth had some genuinely bad news this week.
A White House report that says global warming threatens every part of the U.S.
This isn't something in the distant future. Climate change is already affecting us now.
Now. Smart move, Obama. That is a key shift in how to talk about climate change, because we've all proven that we cannot be trusted with the future tense. We've been repeatedly asked, don't you want to leave a better Earth for your grandchildren? And we've all collectively responded, fuck 'em. But incredibly, this latest damning scientific report may still face an uphill climb with some of us.
There's that Gallup poll that came out last month, which found 1 in 4 Americans is skeptical of all the effects of climate change and thinks this issue's been exaggerated.
Who gives a shit? That doesn't matter. You don't need people's opinions on a fact. You might as well have a poll asking which number is bigger, 15 or 5. Or do owls exist? Or are there hats? The debate on climate change should not be whether or not it exists, it's what we should do about it. There is a mountain of research on this topic. Global temperatures are rising, heat waves are becoming more common, sea surface temperatures are also rising, glaciers are melting, and of course no climate report is complete without the obligatory photo of a polar bear balancing on a piece of ice. The only accurate way to report that 1 out of 4 Americans are sceptical of global warming is to say, a poll finds that 1 out of 4 Americans are wrong about something. Because a survey of thousands of scientific papers that took a position on climate change found that 97% endorsed the position that humans are causing global warming. And I think I know why people still think this issue is open to debate, because on TV, it is. And it's always 1 person for, 1 person against. And it's usually the same person for.
Bill Nye and Marsha Blackburn, welcome both of you to Meet the Press.
Bill Nye joins us now, along with climate change skeptic Mark Morano.
Joining me now to go head-to-head, Bill Nye, science educator and CEO of the Planetary Society.
In the crossfire, Bill Nye, the science guy.
Bill Nye, the science guy who believes in man-made global warming.
Yeah, that's right. More often than not, it's Bill Nye, the science guy, versus some dude. And when you look at the screen, it's 50-50, which is inherently misleading. If there has to be a debate about the reality of climate change, and there doesn't, then there is only one mathematically fair way to do it.
Last Week Tonight presents a statistically representative climate change debate.
Good evening. Joining me tonight, a climate change denier and, naturally, Bill Nye Science Guy. Bill?
John?
Yep.
Humans are causing climate change? No question.
Wait. Before we begin, in the interest of mathematical balance, I'm going to bring out 2 people who agree with you, climate skeptic, and Bill Nye, I'm also going to bring out 96 other scientists. It's a little unwieldy, but this is the only way you can actually have a representative discussion. Please file in. Again, this is going to make the debate difficult. We shouldn't really be having it in the first place. But, representationally, climate skeptic, please make a case against climate change.
Well, I just don't think all the science is in yet. It's settled.
OK, and what is the overwhelming view of the entire scientific community? Well... OK. Any response to that? Any response? I can't hear you over the weight of scientific evidence. This whole debate should not have happened. I apologise to everyone at home. My thanks to Bill Nye and the overwhelming scientific consensus.
All right. So the next probability sampling method that we're going to talk about is cluster sampling. And so cluster sampling is just like random sampling, but instead of selecting individual people, you select groups of people. And these groups are naturally occurring, or they are units of people that exist on their own. In other words, the researchers did not come in and create these groups or these clusters. They already existed. So this could be PTAs. So all of the PTA groups across the United States, in this elementary school, this elementary school, this elementary school, each PTA group would constitute a cluster. It could be football teams. So you have the Chargers, they're a cluster or a naturally occurring group. You have the Patriots, you have the Texans. So you have all of these football teams, and they are representing, each football team is representing their own cluster. And so then what we would do is we would kind of get our sampling frame, and instead of it being a list of individuals, it would be a list of groups, and then we would randomly select these groups using a random number generator or whatever randomization method we chose. So let's go ahead and watch a video now on cluster sampling.
Now let's look at something called cluster sampling. And what cluster sampling is, it's a cost-effective way to sample, because sometimes sampling can be very cumbersome. Why don't we start with an example to kind of illustrate this? Let's say we wanted to do a study on medical students, and we wanted to know if board scores correlate with match results, of getting the first results in their match. So the ideal thing would be to go to every medical school in the country. So I represented the medical schools here with a book with the rod of Asclepius in there and scattered around the country. Now this would be quite a cumbersome experiment to do, because you'd have to go travel to every medical school, or you might email the dean's office of every school and try to get everyone's emails and getting them to answer, and that would just be quite expensive and time consuming. So what we could do instead is break them up into clusters. So a cluster is a group of people or subjects that have something in common, and yet the entire cluster is pretty representative of the population as a whole. So if we're interested in medical students, a good way to cluster is by medical school. So for a given medical school, let's say we chose this one. Maybe this one is UT Houston or Baylor or something in Texas. And all the medical students in there have some commonality in that they all go to the same medical school, right? And do they represent the population? Do all the students of this medical school probably look similar to this, look similar to all of them? Yeah, they do. Medical students in general are intelligent people. They probably have the same 50-50 male to female ratio, probably the same economic status diversity among them. So we could say we're going to make our clusters a medical school. That is what we're going to use as our cluster. So let's move this out of the way. This is our cluster. It's going to be a medical school. And now what we do is we randomly select from our group of clusters. We randomly select some clusters. So we'll pick here, let's pick UCSF. We'll take this one. Let's take Emory. let's pick this one here. We're randomly picking these. Let's say that's Kansas. And you get the idea. You pick a number of clusters that you want to get. Let's say here we leave it at 3. And then you randomly select the clusters. So the first thing we have to do is identify what is a cluster. Then we're going to randomly pick clusters. And then within each cluster, we're going to examine everybody within that school. So we take everyone from UCSF, everyone from Emory, and everyone from Kansas, and then we collect the data we want from them. And so when we evaluate everybody from a given population, and the population here is our cluster, that's called taking a census, right? As like the census that we take nationally every year. So we randomly select our cluster, and then from each cluster, we take everybody in there. So we take a census from within the cluster. So why did this save us any money? Because let's say we were going to do a simple random sample, then our sampling frame would have to be every single medical student in the country. So we would have to get a roster from every single medical school. We'd have to put them together, and we'd have to choose randomly from that gigantic list. Getting that roster would be expensive, it would be time-consuming, and it might not even be possible sometimes. So what we've done instead is we've randomly selected a cluster. And then from within the cluster, we took everyone from in there. And so that saves us some time and money. Now let's just go over 2 more points. Do you have to take everybody from within the school? No, you don't have to. You could do a simple random sample here as well. So instead of evaluating on doing a census, you instead of doing this, you could just take a sample, and it could be a simple random sample, or you could use one of whatever sampling methods that you wanted to. And so what this would be, this is technically called multi-stage sampling, because first you did a cluster, then you did a simple random sample. But you could do that. That's totally a valid way of doing it. So one last point we should make there. Let's take 2 more schools. The first is the University of Smarty Pants, and the second one is the University of Dummies. Now, you could rightfully make the argument that these 2 universities are not representative of the population. The people here are way smarter than the general population, and the people here are not as smart. They're below average. And so these are not representative. And so as being not representative, they don't make good clusters. And so then this would not be a valid sample. Since even though they are homogeneous within their group, everyone at the University of Smarty Pants is highly intelligent, and everyone at the University of Dummies is below average, but they are not representative of the entire population of medical students in the United States, so these are not good clusters. So what do you do in that case? Well, then, you might decide that you're going to make your clusters differently. Let's say we make them geographically. Like, say we'll take the West and Pacific Northwest schools. We'll take the New England Northeast schools. We'll take the Southern schools together. We'll take the Midwestern schools together. And so those are our clusters in this sense. And we see, there's a University of Smarty Pants in each one of those groups, and there's a University of Dummies in each one of those groups. And so those clusters are representative of the entire population. And so maybe that's a better way to form your clusters. So this is cluster sampling here. And remember, the way we do it is first you got to form a cluster, you identify a cluster, and the people within the cluster should have some commonality. That's why they make the cluster, but they should also represent the entire population. Then you randomly pick the clusters. That's the point of the randomness here, is the cluster selection is random. And you can do one of 2 things after that point. You could take everybody out of the cluster and evaluate them. That's called a census, right? And that's one way of doing it. Or you could take a simple random sample out of each cluster as well. All right, so that's our cluster sampling video.
And the last probability sampling method we're going to discuss is called multi-stage sampling. And so it's just cluster sampling, but it's cluster sampling done in multiple stages. So let's say you wanted to study football players from all types of colleges, community colleges, private colleges, state colleges, in all regions of the country, the West Coast, the East Coast, North, South, Middle, everywhere. So that's a lot. You would need to study your population in multiple stages. You wouldn't be able to kind of get that done in one shot. So you might pick a region, you might say West Coast, and then make your sampling list of all of the football teams on the West Coast, randomly select which teams are going to be in your sample from there. And then you move to the next stage of sampling, which is maybe the East Coast. And so you do the same thing. You make a sampling frame, and then you randomly select the football teams on the East Coast that are going to participate in your study. And then you move on to the third stage, which is, let's say, the South. And so you make a sampling frame of all the football teams in the South, and then you randomly select from those clusters to be in your study. And you keep going until you get through the entire geographical area that you're trying to test, or your entire population. So let's now watch a video on multi-stage sampling.
Hi, this video is about multi-stage sampling. It is really similar to cluster sampling. To make things easier, we start with an example. Imagine we got 4 villages, each more or less similar to the next. Our goal is to test 12 dogs if they have certain disabilities. If we would use simple random sample, we could probably end up asking in every village. Imagine if we would have 40 instead of 4 villages. That would make our collection really expensive. We decided to cluster the different villages. Now we use 2 random numbers to get our first and our last cluster. We did this with SRS. In difference to cluster sampling, we use SRS in each cluster. Now we speak to the dog owners in our cluster sample, but only to the selected ones. In the real world, we could break the clusters further and further, down into smaller pieces. A reason why to choose multi-stage sampling is that often SRS is far more expensive. And often it is really difficult to distinguish, so stratified sampling wouldn't be a good idea either. Last but not least, it is more accurate than only cluster sampling. Here is an overview. Thanks.
Okay, so the first non-probability sampling method that we're going to talk about, so switching gears, from the broad category of probability sampling into the next broad category of non-probability sampling. The first method we're going to discuss is convenience sampling, and this is just choosing whoever's available from the population, so whoever volunteers or whoever we can talk into participating. So this is actually the most popular form of sampling in psychological research, and we assume that college students are fairly representative of young people at large, as long as age or education level isn't like a moderating variable or confounding variable left unaccounted for in your study. Then it should be okay using college students as kind of a representative sample of the population. Now, if age is a factor, or income or education level, then it might not be a appropriate sample for the population. But in most cases, this is the method that we use in research, and it is the method that we will be using for our studies. We are going to email professors and let them know of our study, and then offer extra credit. Hopefully they'll do that for us. And then whoever volunteers from that is going to comprise our sample. And so that is convenient sampling. But let's go ahead and watch a video on convenient sampling so we can make sure we have a real clear understanding of what it is.
So, there are many ways of actually gathering data, and this one is called convenient sampling. Well, what is convenient sampling? It's a non-random sampling method that chooses people that is easiest to recruit. By that definition, you might be confused by what it means. Well, for example, the researchers could have chosen the people who's closest to them. That's why, if for psychologist students, you could have chosen your sample to be your friends, your peers. But let's say, why do we need to choose convenient sampling? So we look at the pros. Well, first off, it's cheap, very cheap. I mean, literally so cheap. And it's very easy, right? Secondly, it's useful for pilot research. Ooh, pilot research. Well, and it's good because it's a specific group of people. You can select them as well. And additionally, it's very fast. It's not time consuming. So think about that. For instance, people with hats and mustaches. Yes, these guys. You can choose directly to choose them. Yes. However, there are drawbacks, which the main reason why people don't really choose this, it's you can't generalize to the population. It's biased, very biased. And people could misinterpret the data you collected because it's a specific group of people. In conclusion, the pros. It's fast, it's cheap, it's useful for piloting, and it's a specific group of people selected. Cons. It's biased. You could misinterpret. You can't generalize. So it comes to the point where you decide whether or not to choose it. Well, with all that in mind, I hope you choose wisely whether or not to use convenient sampling. Thank you.
So the next non-probability sampling method we're going to discuss is called quota sampling, and it's like convenience sampling, but the goal is to select participants with specific characteristics until you have enough people to create your sample. And so some examples of variables that we have used quota sampling to measure are socioeconomic status, race, age. And so if you want an equal number of Black, white, and Asian participants, then you might need to engage in this type of sampling called quota sampling, so that you can get the percentages of each variable that you need. If you need 60% elderly people and 20% adolescents and 20% infants, then you can use quota sampling to achieve that. So let's go ahead and watch this video on quota sampling.
Created using Powtoon.
And the last sampling method we're going to discuss is also a non-probability sampling method. It is referred to as referral sampling, or actually more often it's referred to as snowball sampling. And so this type of sampling is a technique for developing a research sample where existing study subjects recruit future subjects from among their acquaintances. So this type of sampling is generally used when participants are difficult to locate. So let's say that you wanted to study people that were engaging in illegal activity, then you might need to do this type of sampling so that the people can feel safe. So for example, maybe you are wanting to do research on sex work, and so you find a sex worker who's willing to participate in your study. You do the research with them, you collect their data, they feel safe, they know you didn't collect any identifying information, they were anonymous, whatever it is that makes them feel comfortable, understanding that this study is just for scientific purposes, no one's trying to get anyone in trouble. And then what they do is researchers will ask that participant, hey, do you know anyone else that would be willing to participate in this study, another sex worker that you might be able to get to participate for us. And so that's the way that snowball sampling happens, is each participant leads the researcher to another participant, to another participant, to another participant, until you get a full sample. And obviously this is quite difficult and very time consuming. So let's go ahead and watch this video on snowball sampling or referral sampling for more information.
Created using Powtoon.
All right, that is it for chapter 6. Thank you for listening all the way until the end. Have a great day, and we'll talk to you on the next one.